Yes. Hey guys, how are you all? How are you all? Arya, how is it going, Arya, for you at school? Doing good?
I'm doing good.
Okay, what are they doing? Dhwani, Krishna, Arya.
They've just done transformations of like graphing rational equations.
Solving rational equations.
Yeah. And then variation, but that was like a while ago.
Oh, variations. Okay, upcoming test is on
Thursday.
Thursday on what, Arya?
Like this Thursday.
Yeah, on what?
Oh, it's like adding, multiplying, subtracting, rational expressions, and
Mhm.
then the word problems, variation, and then graphing rational equations.
Have they covered asymptotes, whether the graph crosses the asymptote, all that?
Yeah, yeah,
Okay, okay, okay. So slant asymptote did they cover?
yeah.
Oh wow, that's too fast. Okay. Shragbi, what is up for you?
We're like doing like rational functions, like radical functions and stuff, like adding, multiplying, dividing, subtracting.
Okay. And for Siddhi and Parvini?
We're doing polynomial functions.
Okay, so it's a little slower. Okay.
We're adding and dividing and multiplying functions like fractions with variables.
Arya or Dhwani, can you circulate the calendar that you have? Or all the 4 9 week you have, huh?
Like syllabus, I sent you the calendar last week
Yeah.
about this unit.
Oh, in WhatsApp, ma?
Yeah, I think you saw it too.
Sweet, yes. Yes, you did.
I can check if there's like a syllabus too.
Hmm. Oh, so you have holiday on 17, 18, 19. There is a test, 20. There is a test. Okay. Graphing rational functions, slant asymptotes. Okay, graphing rational functions. Solving by graphing rational functions. Okay, makes sense. After this, what are they going to do? Do you know?
On Wednesday we're just gonna review for the quiz, and then we're gonna take the quiz on just like I think the quiz is on graphing and variations.
Okay, let's really go ahead. We finished variations, right?
Yeah, we did that last week. You said we were gonna graph this week.
Yeah. Graphing only. Graphing and slant asymptotes, and there are some tricky graphing which are going to take a little tough time from us. Let's see.
Should I send you the syllabus?
All the 4 9 weeks, if you have, definitely send them out.
Okay, I'm sending it to you.
Thanks. Or are you sent to me, and I need to check. Very honestly, I don't remember. I'll have to send check. Oh yeah, send it to me if possible. Okay. Okay.
I sent it.
Thank you. In WhatsApp, huh?
Yeah.
Okay. Graphing rational functions. Let's quickly go over this. See, I follow what to say. Every year I follow. Oh, this is very useful. Okay. 1 second. I just want to make sure whether we are doing everything. This is the third inverse of quadratic. Oh, solving, dividing. Okay, add, subtract rational expressions, functions. Solving rational equations. Graph simple and complicated rational functions, inverse joint variations, radical functions, expressions, and equations. Inverse of quadratic cubic. Fit square root functions to data. Okay, great. So last is exponential logarithmic. Okay, that's good. Okay, that's good to know. Okay, now let's go ahead with graphing rational functions. I don't know what. Okay, see, this is the way. Let me go ahead and show you. I really would love for you to follow this one. Graphing rational functions. There is a cheat sheet. I can print out as well. You won't make mistakes at all if you follow. Okay. In case of rational functions, I want you to follow the process. Okay. If I ask you to graph the function f of x equal to 1 by x, right, guys? Pretty much it's easy when you think about it. When you draw a table, you can say, hey, let me try -3, maybe -1, 0, 1, 3. Independent values you're filling up, and you're trying to find the value of y. What is y? This is 1 by -3. So basically, let me quickly graph and show you. This is just a similar to linear equation graphing, but this is not what we are going to do. However, -3 is -1 by 3. -1 is a -1. And after that, 0 becomes undefined because y value is 1 by x, right? 1 by 0. So that becomes undefined. It just, what did I do? Okay, so it just goes here. It goes undefined, and then 1 is 1 by 1, 1 by 3. 1 is 1. What did I do? I'm making a blunder. -3 is here. -1 by 3 is here. -1, -1, and then it goes to undefined. Right? And then 0 becomes undefined. Again, 1 becomes 1. And then 3 becomes 1 by 3. 3 becomes 1 by 3. So what do you think? It goes to undefined, and then it comes from undefined. It goes like this. Make sense, guys? For the 1 by x graph, it does make sense. However, what we are going to plot is all complicated functions. Okay. I would like you to follow some processes. Some process literally. Okay, let me go ahead. This is the process that I am going to go about. It is so easy to follow and you will never make mistakes. Okay, these are the things which I want to discuss with you. I will upload this in Google Classroom too. Okay, when it comes to graphing rational functions, we'll go slowly, but I want you to understand and do more. Okay. When it comes to graphing rational functions, right? Let me go ahead. I'll go ahead and try this. We solved rational equations, I know. Just a minute, guys. But let's solve without a let's solve not a complicated function, okay? How about this? I'm going to do simple rational functions first and then we'll move on, okay? I showed you 1 by x. So now for the 1 by x thing, right? What is the domain range? I really want you to understand what is the domain range of the function. How about this? For this function, we just graphed f of x is equal to 1 by x, right? Pranav, did you have a question on graphing this? Did you have a question on graphing that, Pranav?
Miss Priya, are you talking to me or the?
What is it?
Are you talking to me or the? Oh, sorry.
You.
The other Pranav isn't here today. No, I don't.
Okay. Now, so what is the domain? What is the range?
Like it's all real numbers except 0
So
for
how,
both of them.
how do you write it? So
It's like
inside
that R and then you get.
not equal to 0. Can I say this?
Okay, yeah, we did it in school differently.
Or I can as well say minus infinity comma, 0, 0 is not included, union 0 to infinity. You see, minus infinity to infinity you can't say because 0 is undefined. So 0, you put a break here. Again start at 0, but 0 is not included. Parenthesis comes. You put a union symbol, means this and this. Okay. Union means in addition to the left, right is also included. This and the right is included.
Miss
Now,
Priya,
yeah, ma?
I have a question. So if they say to write it in interval notation, which one would you use?
Oh, interval notation is this, ma. This is set.
Okay.
You got it?
Thank you.
Now, range means, range is also the same thing, right? Goes from minus infinity to 0. 0 is not included, and then 0 to infinity. Make sense? How is the end behavior, guys? As x tends to minus infinity, what happens to the graph? Y tends to? Guys, you have to shout out.
Minus infinity.
Really? Think about this point in the graph. X is minus infinity. Y tends to?
Infinity.
Wait, ma. As x, guys. X is going to minus infinity. Where does y go?
Oh,
Zero.
y equals 0.
Yes. As x tends to infinity, where does y go?
0.
Y goes to 0. You all got it? Think about this point in the graph. Then you will be able to say. Okay, can I move on? Okay. So the 1 by x graph is so easy to do, right? Okay. How about this? 1 by x minus 3 graph. When you think about it, you know transformations already. So what is this transformation? My parent graph is this. We already drew and saw. My parent graph was like this, right? So for this graph, what will you say? What is that graph? It's what type of a translation it is? Translation or transform?
Right.
It is?
The right by 3.
Yeah, the 3 units to the right, right? So what happens if it moves 3 units to the right? Okay, one thing, guys. In a rational function graph, 1 by x graph, right? This is a 1 by x graph. There are two asymptotes. One is a horizontal asymptote. This is your horizontal asymptote. What is that? Why is it called a horizontal asymptote? That is y equal to 0. Why? It's the horizontal line to which the graph is trying to merge, but it will never merge. Similarly, 0 was undefined. Remember? This is called the vertical asymptote. Why? Because this is the line to which the graph is trying to merge almost, but it is not merging. Got it? There are two asymptotes, horizontal asymptote and a vertical asymptote. Now let's get on to f of x equal to 1 by x minus 3. You all know that this is a horizontal shift to the right by 3. Any questions on that? If it is moved horizontally to the right by 3, tell me what will be the horizontal asymptote, what will be the vertical asymptote?
It'll be x equals 3 for the vertical asymptote and y equals 0.
Exactly, the asymptote moves. This is my asymptote, this is my asymptote. However, my graph, let me do it in a very different color, okay? This is the graph. So green color graph I'm going to draw. How am I going to draw? The graph is going to be like this. It moved to the right by 3. Any questions? Otherwise, you can also draw the table, okay? Drawing the table is all old school now, okay? We're all gone past that. You can draw the table and verify. But a quick way to check is, oh yes, it moved to the right by 3. This is the way. Now, let's go ahead and try this one. How about this? How about this? Okay, we're not going to graph now. We're going to guess the transformations. Okay, so how about this? Minus 0.5 by x. What is this? What is this transformation? Try, guys. Meaning I'll help you. Dhwani, you want to try, ma?
Sure. It's a reflection over the x-axis.
Reflection. This minus is a reflection on x-axis. Then
And then it's a vertical compression by 1/2.
Compression by 1/2. So what happens? Do you see? There's a vertical compression. Don't worry about it. That we can do a table and find it out.
Like the two lines now are on the second quadrant and the fourth
Exactly.
quadrant.
Exactly. The parent graph was this, remember? 1 by x graph. Reflection on the x-axis means the graph reflected on the x-axis. This part reflected like this part came here. So the graph came to the second quadrant and the fourth quadrant. That is the reflection on the x-axis. Vertical compression by half means you don't need to do it now, but the y coordinates are multiplied by half. Y coordinates get multiplied by half. That means what? You know, for any graph, we have 3 reference points. For any graph, we will have 3 reference points. Okay, for this one, what are the reference points? What will I say about my reference points? See, earlier my parent graph was this. My reference point is 1, 1. You have to show where does this 1, 1 transfers to in the transformed graph. The other reference point is minus 1, 1. 0, undefined can be another. You see, these 3, how they move is what you need to show. When you have a vertical compression by half, the y coordinate will get multiplied by a half. You got it? We'll see one by one we'll do though. Okay, now how am I going to, what is this? I really want you to be able to guess this. How about this? Minus 2 times 1 by x. What is this graph, Arya?
Okay, so this is a reflection over y,
Correct. Good.
and then I think it's horizontal.
Why am I horizontal?
Vertical stretch by 2.
By 2. Good job. Suppose if it is like this, maybe, Krish, do you want to give it a try?
Sure.
1 minute, 1 by 2x. How about this?
Reflection over the, is it x-axis?
Let me put it like this. Yeah.
X-axis,
Because
then
the y coordinate is negated,
yeah,
right? Go
and
ahead.
then horizontal compression by 1/2.
Good. For this one, you're going to take the reciprocal because any horizontal compression or stretch, you're going to find the reciprocal. Got it? Okay, now let's try. How about this? We are going to now graph, okay? Or maybe one more, I can give it a try. But you guys are good. Okay, let me go ahead. Okay, now, if I give you to graph, right, I really want you to find out the transformed functions. Let's see. Now, there is a function g of x will be equal to 3 times 1 by x minus 1 plus 2. You're given this, okay? The way I graph it, I would like you to follow. Honestly, you won't make mistakes, I promise. Now, let's see. First, let me write the verbal description. Now, when I want to write the verbal description of this, right, it is a vertical stretch by 2. Please let me know if you didn't understand. Vertical stretch by 2. Then,
It's a vertical stretch by 3, right?
sorry. Yeah. Right by 1, up by 2. Make sense? Okay. So, we've got the vertical description done. Okay, you know what I do? This is what I do. Okay, this you won't make mistakes. Okay, this is my parent function. I draw my table. Okay, this is my parent function. This is my transform function. But in the transform function, how did my x change? How did my y change? I have to be very clear. Then only I can plot the points. You got it? So for me to plot the point, let's see. Now the thing is, for the transform function, vertical stretch will apply to the y coordinate, right by 1 will apply to the x coordinate, up by 2 will apply to the y coordinate. Am I making sense? Why? Sitara, am I making sense?
Yeah, you're making sense.
Okay, Shragvi, did you get it? Siddhi, did you get it?
I get it.
Yes.
Okay. So now I said, right, I will always check for the vertical asymptote. Where was the vertical asymptote? X equal to 0. This was undefined, right? Now again, y was okay. The other two ones were -1, comma -1, 1, comma 1. I really want these points on the transform functions. Then only my graph will become correct. Okay. Here, let me understand what is the horizontal asymptote, what is the vertical asymptote. You tell me, guys. First, it went up by 2. So basically, the horizontal asymptote went up by 2. What is the horizontal asymptote?
That's y equals 2.
Y. So let me write down. Horizontal asymptote y equal to 2. What is the vertical asymptote?
X equals
Mm-hmm.
-1.
X equal to, really ma? X equal to 1 or -1? Because
1.
1, yes. So now I'm going to first plot it. Okay, this is my graph. Y equal to 2, x equal to 1. I'm going to do this graphing, this plot. Please draw it in dotted lines. Okay. So here it is. So this is x equal to 1, my vertical asymptote, y equal to 2. You won't make mistakes really if you follow y equal to 2. That is my horizontal asymptote. I'm done with my asymptotes. Okay. Can I move on? So x equal to 0, y equal to 0. This is what x equal to 0 move to x equal to 1. Y equal to 0 move to y equal to here what 2. Okay. Can I move on? Can I go ahead? Now I want to plot my reference points. See here, how did the x change? X coordinate is affected only by this. Right by 1 means I should apply x plus 1. Correct? And then for y, what is the change I'm going to see? For y coordinates, it's multiplication by 3 and then add 2. So multiplication by 3 and add 2. Any questions? Okay. Now, directly you're going to plug in values from here. This is not hard. X plus 1, x plus 1, 3y plus 2. 3y plus 2 means -3 plus 2. 3 times 1 is 3 plus 2, 5. So my points went to what? 0, comma -1 and 2, comma 5. Where are my points? 0, comma -1. I want to plot in a different color. It's so hard. 0, comma -1. Then the other point is 2, comma 5. This is 1, this is 2. So this is 2, 3, 4, 5. You see, guys, do you see how it changed? So this is my graph. This is my graph. Any questions here? Any questions? Write the verbal description. Write which coordinates are affected. Okay, put your parent function, transform function, the table, and how your x and y coordinates changed. Write out your horizontal asymptote, vertical asymptote, and then how -1, comma -1 changes and 1, comma 1 changes. Plot the points, graph it for simple rational functions. Can we try one more? I want to do this one. Next one you can do. Can I go ahead and do? Guys, if this is too easy, I don't want to waste time as well. Can I go ahead?
Yeah.
The same function, yeah. For the same function as well. Okay, let me go ahead. I'll plot it. I'll plot it first. Okay, how about this? G of x, these are all easy functions which we are discussing. But the problem comes when we go to complicated function. I want to follow this process. Okay. Now, this one is again a simple function. Okay. But plotting is going to be a little different. How about this? I know here, what am I going to write? Verbal description, right? How did it transform? My parent rational function moved left by, first I'm not going to write the translation. First I'm going to write compression or stretch. So what is that? What is that, Amma? Anybody can say.
Horizontal compression by
Yep, horizontal
one
compression
half.
half. Then I can go to translations, okay? Right by 3, down by 1. Now when I write it, this affects the y-axis, this affects the x-axis. Horizontal compression means x-axis. Now my table comes into picture. Parent function, transform function. Parent, transformed, x comma y. So the asymptotes were, I will, the first 2 lines are just the asymptotes for me. Okay, so I will not draw like this. I will just draw like this. So x equal to 0 is an asymptote, y equal to 0 is an asymptote. The same I need to do here. However, x and y, how did it change? That I don't know. X. Let's consider first x. I'll go here, I'll see how did it affect. I have to multiply by half and add 3. Multiply by half and add 3. Y, how did it change? Just -1. Am I making sense, guys? Siddhi, was it clear?
Yes.
Okay, good. Now, let me find the asymptotes. What are the horizontal and the vertical asymptotes? X moved left by 3. So what happened to the vertical asymptote? Anybody, guys, please?
Uh,
Go.
positive 3.
Hmm?
The vertical asymptote is 3.
X will be equal to
3.
3 or -3?
3.
Why? Oh, yeah, it moves right. Right. Did it move right?
Oh no, the
It moved to the left or right, guys?
left.
Left by 3, right? Okay, go ahead. So that should be x equal to
-3.
-3. Y will be equal to
-1.
-1. So those are the asymptote. X equal to -3. Y will be equal to a -1. Those are my asymptotes. Okay. Now, I have only 2 points, -1 and 1. But what I need to apply, I already know what I need to apply. So plug in the value of -1. So what happens? This becomes -1/2 plus 3. So that will be -1 plus 6 by 2, 5 by 2. That's what I get here. I get a -2 here. I get a 0 here. If I plug in 1, what happens? Parvini, are you following?
I'm taking notes.
So it's like that, huh? Okay, 6 plus 1, 7 by 2. So basically this is 2.5. This is 3.5. Arya, you're following, right?
Yeah.
Okay. What I'm not getting is half x. See, okay. See, here it's a minus of -3 means x moved to the left, right? This is a -3 or a +3, guys? -3, correct? -3, see, -6, -7 by 2, -7 by 2, and then a -6 by 2, -5 by 2. So this is a -5 by 2, this is -3.5, -2.5. Please, that's a correction. Just because I took it wrongly, first everything came out wrong. Did anybody not understand anything of this? I'm here to clarify. Pranav, are you following?
Yeah.
Pranav, okay?
Yes, Miss Priya.
Okay, now I drew this. I'm going to plot out the points. -2.5, comma, -2. -2.5, comma, -2. -2.5, comma, -2 is here. Right? And then the other one is -3.5, comma, 0. So -3.5 is here, comma, 0. Am I making sense? So my graph is going to be like this. Did you all get it? Yeah, did you all get it? Did you all get it?
Yeah.
Move to the left. Okay, correct. Move to the left. Okay. Left by 3 and then did we do it correctly? Something feels so wrong to me though. Are our points correct? Minus 3.5, minus 3.5, comma minus 2, then minus 2.5, comma minus 2, and then minus 3.5 is a 0. Correct, but I just want to. Somewhere something feels wrong though. Minus 2.5, comma 0. Do you see any mistake, guys? I feel something is wrong. You know what is wrong? Do you see what is wrong about it? Guys, do you see what is wrong about it? I do see something very blatantly wrong. What is wrong about the graph? You can tell me the mistake as well, meaning you can find out what is the error, blatant error that is seen here. See, that's also a skill, right? What is the problem here I'm seeing? I'm seeing a problem, definitely. I don't know what is the problem yet. I know what is
I
the
don't
problem.
think I see one, Miss Priya.
It looks correct. No, right? But see, am I mistaken? My usual graph is like this, right? Then in that case, why did it shift to the left? Meaning, see, the graph shifted to second and fourth quadrant, right? It should not have. There is no negation. You see what I mean?
So then why did you write negative 2.5 and negative 3.5 when you crossed out 5/2 and 7/2?
Basically, see, this was x minus of minus 3, right?
Yeah.
So there is a half multiplication with x, and then I need to subtract 3, not add 3, correct?
Yeah.
That's why. So when I substitute minus 1 area, 2 times minus 1. I'm substituting minus 1 means I will have to do half times minus 1 and then subtract 3 area. That is why I myself am a little confused. Hold on. Minus 1 and
Yeah.
then minus 6 by 2 is minus 7 by 2. That's correct, right?
Yeah.
So I don't see any error, but somewhere something is not right. Minus 2.5 comma minus 2. Minus 2.5. Minus 2.5 comma minus 2. Oh, this is losing battery. Hold on. I'm sorry. Give a minute. 1 minute, guys. Sorry. There is a mistake for sure. I need to check what is the mistake. Dhwani, do you see the mistake?
I don't see it, but like I also don't do it this way. So
Oh, you don't do it this. Okay. Okay. So can you graph that and see what you are all getting?
should I do it using like to check the accuracy? Should I do it on the graphing calculator or paper?
Do you all do in the graphing calculator?
No, not in school. Like I was just asking if you wanted
No,
thought
I would like you
something
to
wrong.
do yourself in your own way and tell me what is the graph you get, right?
Okay.
There is a blatant mistake. I'm seeing that it shifted to second and fourth quadrant when it should not be, right? So let me also find out the error,
Wait,
guys.
Miss Priya, this is just a guess, but would you put the 1/2 in the transformed x in like would you put x minus 3 in parentheses and apply 1/2 to both? at all, or
First I will multiply by half x and then a -3. Always we should perform the compression stretch and then translation. Good question. You see what I mean?
yeah.
What I'm saying is, hold on, let me as well check. -3.5 and then y -1 was a -2. -3.5 and a -2, -3.5 and a -2. I think, okay, did I do my points correctly? Plotting of the points correctly, I doubt. Hold on, let me see. There is some mistake in the graphing. Hold on. I have a pen problem as well. Hold on 1 minute. It's not working. Okay, what is the mistake here? Y equal to -1, x equal to 3, correct, -3. That is correct. Asymptotes are correct. And the values are -2.5
Miss
and
Priya,
yeah, ma?
I was trying it like when I was graphing, I was trying to use like the value of x as like -4 to like get it like to graph it, and like I don't get 7, whatever, like 7/2. Why did you choose that x value?
Oh, you're not getting 7. I'm getting -7/2.
Like, why did you choose that x value though?
Because when I translated -1 and my -1 point, where did it move to?
Oh, that's how you, oh, okay, I was doing it different. Okay, never mind.
Yeah, the -1, see, wherever the reference point moves, you should know where the reference point moves, right? What is the point you're getting?
I don't do it with the reference points. I was just substituting in values after the asymptotes to do it.
Oh, so after you get the asymptote, you try to substitute x values here, huh?
Yeah, because the graphs we have graphed in school, usually it's just vertical, so we don't even need to substitute it, because like they taught us a way of like just doing it like that. Since it's horizontal, I was just substituting in values after the asymptote too.
Okay, can you tell me where the -1, -1 point moved to? You see what I mean?
Well, yeah, the original point over there in the x-axis, -1 moved to -4, and then the y value -1 moved -2.
It can be -4, Emma. Half. Did you multiply by half?
Oh no, I forgot. Sorry, -2 then.
So it's -2.5, right?
Wait, what? How
Minus
is it 2.5 if it's like -2 divided by 2?
So what is the point it moved to, you're saying?
It would move to -2, right? Because if your point is -1, -1 is translated 3 units to the left, and it's divided by 2. That's -2, right?
So -1 gets multiplied by half, okay, and then subtracted 3. So -1/2 -3 is -1/2 -3 is -1/2 -3. Yeah, -1/2 -3 is -3.5, right?
Oh, I was doing the thing in the parentheses first, like how it's x. Okay, I was doing. Oh, no man.
Pranav, did you see the mistake, or Krish, are you seeing the mistake? Krish, where are you? I see the mistake.
Yeah, Miss Priya, I redid the graph. I got something different.
What did you get?
My 2 points were -2, commas -0.5, and -4, -1.5.
What are the points you're getting? Come on, tell me.
Like from
Hmm.
-3, I substituted -2 and I got a -0.5, and I substituted -4 and I got -1.5.
Oh, these are the points you're getting?
Yeah, the graph is not negative. The graph you have is negative. I think it's a
Yeah,
positive.
yeah, I understand, but the graph should be like this. But
Oh, okay.
points are not evaluating correctly, right? Hold minus, so Arya minus 0.5 and minus 1.5 are the y values you're saying, Arya. Is that so?
Yeah.
For 2.5 and minus 3.5? Minus 2.5 and minus 3.5 is x values, correct?
No. I
What
don't.
are
My two x values were -2 and -4 because they're on either side of the asymptote.
oh, so you just so you're just substituting it directly in this, huh?
Yeah.
Okay. See, always okay. I see. I see. I see. So what did you get answers? -2 and 2. What did you get for x values? Please tell me the 2 points.
So the first point was -2, -0.5.
-2, -0.5. Uh-huh. Then
And then -4, -1.5.
-4, -1.5. Okay, let me please check once. Okay, see, I need to plot the reference point. So it is minus, yeah, -1, -1. That is correct. Oh my gosh. -1, -1 is correct. And -1, -1 shifted to -2.5, 2, -2. Something feels so wrong. So there is a half multiplication to x and then a -3.
I also got the exact points.
Which one? -2, minus 0.5.
Yeah.
-1, -1 became, it was multiplied by half. Okay, so it's -1/2. -1/2 -3 is what? 5 minus 5 minus 1 minus 6 minus 6 minus 3.5 minus 3.5 comma minus 2. What did I make a mistake on? Hold on, you're also getting these 2 points, right? Let me quickly check, guys. I really want to get this done properly. So I have -1 points. Let me substitute and see. -1, if I substitute, minus half, -3. I know the mistake. -1 -6/2 is -7/2. You know what? This is the mistake. I switched the points. This is -3.5. This is 2.5. That's all. See, this is -3.5. This is -2.5. Then I get it. Yeah, I think I get the graph now. Let me go in a green color. So let me then see our mistake as well here. So -3.5, comma -2. -3.5 means after the asymptote, comma -2. See, the points move here. That is correct. And -2.5 before the asymptote, and that's a 0. Oh, wow. Okay, that's it. So the graph should have been like this. So I switched the points. Okay, you see, I'm okay with you guys doing this or doing this. Either way, it's okay. For me, I need the reference points to be plotted for any graph. Because why? Sometimes, see, if the reference points are not there, right, there is no way for me to check the answer with you. You might have chosen -2, -4. One another kid might have chosen -1, -3. One another kid would have chosen 1 and 4. So there is no way for me to verify the points properly. So that's why I always go with reference points. No problem. Can I move on? Is it okay? Shrag, are we okay with this?
Yeah.
Okay. Krish, okay, Krish, you're there. Okay. How about this? Minus 0.5, 1 by x plus 1 minus 3. For this graph, okay, when you graph it, right, I would just like to know where did the 1 comma 1 point move? 1 comma 1 point moved to what point? I would really like to know that. And I would also like to know what is the domain and range of the transformed graph. After doing this, please, let's move on to the complicated ones. Can we do this, please?
Miss Priya, do you want us to just give you the new coordinate point for 1, comma 1?
Yeah. I'm okay with you just doing this. If you know that, then you know how to graph. And then the domain and range. See, but only you graph it, then you can, domain and range you can find actually. It's not a big deal. Where did the 1 comma 1 point move? I would like to know in the transformed graph. Second one is, what is the domain? What is the range? Dhwani, that should be good, right? Dhwani, you're able to do, right?
Yeah, I just sent my coordinates. I'm sending you my domain and range.
But if you didn't get it, Siddhi, you're able to do? Minus infinity to minus
Yes.
1. Minus infinity to minus 1, correct. Chat and open. Here itself you can bring up the chat. Yeah. Minus 1. Okay, nice. Siddhi, correct. Sitara, there should be a union as well, ma'am. Either Dhwani or Siddhi got the transformation incorrectly. 1 comma 1 moved to, I don't know how you guys calculate this. Siddhi got it right. Minus 3.5. Dhwani, 1 comma 1 did not move to minus 2 comma minus 3.5, ma.
Okay, I'll do it again.
You want to check that?
Yeah.
Yeah, that is right. Pranav got it, Siddhi got it.
Oh, I accidentally did -1 for x instead of 1.
Oh, I got it. Shragvi, correct. Range as well, Shragvi. You should have a union, right, Shragvi?
Oh yeah.
Range as well, it just proceeds, right? Do you see what I mean?
Yeah.
Yeah, don't forget that second one.
Okay.
Yeah, Arya, that's right. Arya, 3.5, Arya.
And in what notation do you want the domain range?
I'm okay with this notation.
Okay.
Interpretation is okay. Arya, this one, right, Arya? 1 comma 1, how does it shift? So basically, I am seeing reflection on x-axis, then reflection on x-axis, vertical stretch, vertical compression by half, right by, left by 1, right by 3. So how does it affect? Arya, your point seems incorrect. So here it affects the y-axis, vertical compression y, x, y. Right by 3 is x. I'm sorry. Right by 3, up, down by 3 is y. So now, how does the y coordinate is the problem on for you, Arya? So y coordinate is 1. So it is first negated and then it's multiplied by 2. That gets you to minus half. And then Down by 3 is a minus 3, right, Arya? So it is becoming a minus 3.5, right, Arya?
Yeah.
Not a 3.25, right?
Yeah.
Can I move on?
Mhm.
Okay. Now, there will be some equations which will not be able to see if they give you like this, how to graph this. For these rational functions like these, I would like to go ahead and do the same process for everything. One is I would like to find the horizontal asymptotes. How to find the horizontal asymptote? Consider the power degree of the numerator here is 1. I will consider it as 1. Degree of the numerator m is equal to 1. Degree of the denominator is equal to again 1 here. Okay. Now, to find the horizontal asymptotes, there are 3 cases. One is m can be less than n, or m can be equal to n, or m can be greater than n. Am I making sense? So now degree of this means x power of 1, x power of 1. Both are equal here. Okay. Sometimes my degree of the denominator can be less. See, 1 by x. Degree of the denominator is less means the horizontal asymptote is y equal to 0. Okay. But when they are equal, right? You know what I do? I divide 3 by 1, meaning I divide the coefficient of x in the numerator by coefficient of x in the denominator. So my horizontal asymptote will be equal to y equal to a by b. What is a and b? A is the coefficient of x in the numerator. B is the coefficient of x in the denominator. Sitara, are you following? Now, when the degree of the numerator is greater than the denominator, there is no horizontal asymptote. This is quite important, guys. How to find the horizontal asymptote when numerator and denominator have different powers. Powers meaning degrees. Okay. Okay. This is how you find the horizontal asymptote. In our case now, do you see which one works? The horizontal asymptote. Here, the degree of the numerator is the same as the degree of the denominator. So, our horizontal asymptote is y equal to 3 by 1 or y equal to 3. Any questions? Okay. Now, let me go ahead and see for holes and discontinuities. What
Miss
is
Priya,
Yama?
shouldn't one of them be slant? Like, if the one on the top is greater than the one on the bottom, shouldn't it be slant?
Yeah, there is no horizontal asymptotes, ma. There is a slant asymptote.
Oh, okay. Sorry, I didn't.
No problem. We are only considering horizontal asymptotes. Okay. When the degree of the numerator, like you have x square by x means, see, this is the place where you don't have any horizontal asymptotes. However, we get to have slant asymptotes, which I'll discuss a little later. I'll discuss in 2 more problems after. So now we know how to find out the horizontal asymptote. So we know how to find the horizontal asymptotes. Now let's go over and find what are holes and discontinuities. Now guys, in this scenario, in the current scenario, I don't have any holes and discontinuities. When will there be holes and discontinuities? You remember when we solved rational expressions, we excluded values. Suppose if you're able to factorize a rational expression like this, right? When you're able to factorize like this, we cancelled, right? At that time, whatever factors you cancel, right, x equal to 2 is a whole. That means at x equal to 2, the function is undefined. That is a whole. Here, you don't have anything to cancel between numerator and denominator. So there are no holes or discontinuities. If there is something to cancel, then I will say there is a hole or discontinuity. Can I move on? What are vertical asymptotes? Okay. What are vertical asymptotes? To find out vertical asymptotes, go to the denominator. Okay. find out the linear factors of the denominator. X minus 1 is a linear, x minus 1 is a factor. So x equal to 1. Whatever is the factors in the denominator, they are vertical asymptotes. All factors of denominator are vertical asymptotes. Sometimes you'll have two vertical asymptotes. So you know how to find out horizontal asymptote, you know how to find out holes or discontinuities. Whatever linear factors is getting cancelled between numerator and denominator, those are holes. That means x equal to that point is a hole where you don't have a y value. Similarly, coming to vertical asymptotes, you will go for the factors of the denominator. Any questions still here? Any questions? Now, how do you know that the graph crosses the x-axis? How to find out the zeros? Zeros means what are the places where the graph crosses the x-axis, right? How to find out the zeros? Go to the numerator, factors of the numerator. Go to the numerator, check for the factors of the numerator. Make sense? After all this doing, plot the graph and we can write the domain and range. First, horizontal asymptotes, holes and discontinuity, vertical asymptotes, zeros. And after that, I'll go plot the graph and then I'll find out the domain and range. Last point, how do you determine symmetry? The graph has even symmetry if it is symmetric about the y-axis. This we already discussed, just a revision point. When it is odd symmetry, it is symmetric about the origin. Any questions here? So we have explained what is horizontal symmetry, holes and discontinuity, how to find out the vertical asymptote, how to find out the zeros, which are the factors of the numerator, and then symmetry piece. Can I move on? Okay. Now let's go ahead and try this one. Let's find out this one. I want you to do a simple one. X minus 4 by x plus 1, x minus 1. Here, how are we going to graph it? So here, how do you find the horizontal asymptote, guys? Degree of the numerator less than the degree of the denominator. So how do you find the vertical, how do you find the horizontal asymptotes?
Is it zero? Is it 0?
Yeah, y equal to 0. Okay, so now our graph y equal to 0 is your horizontal asymptote. Now, then let's go to, what did we find? Holes and discontinuity. Are there any holes and discontinuities? Is any factor cancelled? No, so none. Now, the next one is, we write for a vertical asymptote. Go to your denominator, factors of your denominator. X equal to minus 1,
1.
equal to 1. So here, did you see there are two vertical asymptotes? This is making it a lot complicated. So x equal to 1, x equal to minus 1. Okay, that is hard. Okay, I really need another 10 minutes for sure. Now, vertical asymptote is done. Coming to zeros of the function. How to find out? Go to your numerator, x equal to 4. That is where, that means what? Zeros of the function means if you substitute x equal to 4, y value is 0. So 4 comma 0. What is that 4 comma 0? Phase the graph cuts the y-axis. So that's a point for the graph. Make sense? Okay, so I'm done with horizontal asymptote, holes, discontinuities, vertical asymptote, and then the zeros. Now, how am I going to plot the graph? You know, I have divided this as minus infinity to minus 1 to 1, 1 to infinity, right? Now, the best way to plot this graph is, I need to understand, was there any, yeah, horizontal asymptote is already drawn. This is my horizontal asymptote. So, I don't know how the graph is going to go at all. நேத்துக்கு பண்ணது என்னடா 100%. பிரிச்சு என்ன பண்ணு. Okay, பிரிச்சு என்ன பண்ணு. So now let's go ahead and try this one. For this interval, right? What points can I substitute? Can I substitute a point which is to the left of minus 1? Can I substitute, let's say, minus 5 and see? So it's going to be minus 9. If it is minus 5, it's going to be minus 4 and then a minus 6. So it's going to be a very small positive value. So if I substitute minus 5, it's going to be a very small positive value. Now, can I substitute minus 2 in my equation?
Miss Priya, wouldn't it be a negative value?
Minus 9 by minus 24 plus, oh yeah, it's going to be a negative value. Thank you. Good job. So minus 9 by plus 24 makes it a negative value. Good job. Now, I'm going to go ahead and substitute minus 2. If I substitute minus 2, what happens? Minus 6. Minus 2 plus 1 is going to be minus 1. Minus 2 minus 1 is going... Oh, good. Minus 2 minus 1 is going to be minus 3. As a result, this is also going to be a negative value. But do you see here? It's going to be a bigger value, meaning, hold on. So this is going to be 3. It's going to be a minus 2. Even more bigger negative value. So definitely my graph goes like this. Any questions? Then let me come to the next interval. In the next interval between minus 1 and 1, can I substitute a 0 and see? Minus 4, I substitute here 1 and a minus 1. So that gives you a positive value. What is that? 4. 0 gives you a... I'm a little off. Wait. 0 gives you a negative 1, correct? 0 minus 4 minus 4. So 0 gives you a 4. Okay. Now I really want to understand. See, minus 1. If I substitute a minus 0.5, what happens? I really want to see because I don't know how this graph goes, right? So for me to understand, I would really substitute minus 0.5 and see. So minus 0.5 minus 4 divide by, if I substitute minus 0.5, this is a 0.5 and then this is a minus 1.5. So basically, this is a negative value denominator. Numerator is also a negative value. So minus 4.5 by 0.75. So it's going to be a, both are negative, so it will be a positive value. Positive value in the sense it is going to be what? If I substitute minus 0.5. So that is going to be minus 4.5 by 0.75. So that will be 450 by 75. So what will I do? 3, 1, 20, 208, 6. So see, so here the graph goes like this for me. Do you see, guys? Am I making sense? Within this interval, it's I don't know. We didn't see the rest of the graph. So basically it is going, let me plot the points on the graph. Okay. Suppose if I substitute plus 0.5, let me substitute plus 0.5. So it is going to be minus plus 0.5 means let me erase whatever is not required. If I substitute plus 0.5 as x value, what happens here? 0.5 minus 4 divide by 1.5. 0.5 minus 1 is minus 0.5. So this will be 5, 5, 25, 2, 5, is 5, 6, 7, 0.75 minus 0.75. On top, I have minus 3.5. So that gets you to 350 by 75, which is positive again. So which is positive again. But you know what? 350 by 75 is a lower value. Do you see guys what happens? So, are there any other zeros? 350. Are there any other zeros? 350 by 75 is 25 times 3, 25, 1, 10, 100. 100 means 4. So, 3, it'll be 4. Okay, 4 point something. So, it goes here, guys. So, now, what will be the rest of the graph? The graph has to go from here. See, so I see that graph is going like this. Then the graph goes like this. This 4, 0. 4, 0, does it cross the horizontal asymptote here? Yeah, 0 is 4, 0. And the horizontal asymptote is, oh yeah, it crosses. Do you see, guys? Any questions on this? Let's check this graph. I clearly doubt x minus 4, x plus 1. So if I want to check it, I'll go to Desmos. Let me do it, guys. Desmos graphing calculator. I don't have the graph for that one. Let me see. F of x equal to, what was the question I gave you? X minus 4 by x plus 1, x minus 1. X 4. Let me make them by x minus 4 divided by x plus 1, x minus 1. Yeah, the graph is correct. Do you want me to share and show you? We did it right. So let me share and show you, please. Share. I'll go to Desmos calculator. Where is my Desmos calculator? Do you see? That's the same graph we got. You get it? See, at 4, 0, it crosses the horizontal asymptote. Very rarely graphs cross horizontal asymptotes. So here, do you see the point here? We had those points. There was a U up there. This was the graph. Makes sense? Okay, so let me go ahead and give you homework only on this. The thing that I have not covered is horizontal slant asymptotes for the graph. Let me see, guys. Let me ask them whether they can wait for another 5 minutes. Does that make sense? Can I do one more problem in this? Hey, geometry kids, can you wait for another 5 minutes, please? Let me finish with algebra 2. Geometry kids, you can have your videos off. I will start at 7:15, please, just for today. Okay. This class, I'm going to make some changes with the time. It's really becoming heavy on me. Okay, let's go ahead. I'll share this. Yeah, let's go ahead and do one more. But the same, meaning I'll cover the same thing with one slant asymptote at least. So x square plus x minus 2 by x plus 3. In this case, how to graph this? Come to horizontal asymptotes. Clearly, m is the degree of the numerator, n is the degree of the denominator, m is greater than n. So what happens here? If m is greater than n, that's a difficult one. There is no horizontal asymptote. However, in these cases, see, you can perform a polynomial division. Do you see? Like this, you can perform a polynomial division. So we have to rewrite this equation into a form with this. How? When I divide this, I get x square plus 3x. Subtract both, you get minus 2x, minus 2. So this becomes minus 2x, minus 6, and the remainder is 4. Any questions here? Any questions here? So in this scenario, I can rewrite my equation as the quotient x minus 2 plus 4 by x plus 3. Am I making sense, guys? Are all of you clear? Manav, the Pranav, are you clear?
Yeah.
Sitara, are you clear? Pranavi, Parvini, are you clear?
A little, yeah.
Remainder by the quotient. So I changed my entire function as this. Now the problem here is, since there are no horizontal asymptote, this line, you have to plot this line x minus 2. X minus 2 means what happens? It moves to the right by 2, x minus 2. So this line becomes your slant asymptote. This x equal to 2 is your slant asymptote. Now coming to your vertical asymptote, what is your vertical asymptote? X equal to minus 3. That is your vertical asymptote. See, this is your vertical asymptote. This is your horizontal, this is your slant asymptote. In cases where there are no horizontal asymptote, you will have to perform polynomial division and write out in the format quotient plus remainder by divisor. Quotient plus remainder by divisor. If you do that, whatever quotient you get is your slant asymptote, which is a line. Make sense? Now, for you to find out how the graph goes, right? One another thing, I did not find the zeros. What are the zeros? X square plus x minus 2 equal to 0. You'll have to factorize this, right? Minus b plus or minus b squared minus 4ac divided by 2a. Minus 1 plus or minus 3 by 2. So minus 4 by 2 or 2 by 2, which is minus 2 or 1. So basically x equal to minus 2, x equal to 1. Both are, I am getting both as zeros, meaning there the function reaches the x-axis. So both are points, you see. So what I'll do now, minus infinity to minus 3, I'll substitute some values and find out points on the graph. Okay, so the line is going to go like this. So I will find out some points on the graph, how it is going to go. So here, when you look, when you substitute literally points between this interval, and this interval, right? The graph goes like this, basically. Here between this, it goes like this. You'll have to substitute points between this and this. Then you'll have this U curve. You'll have to substitute points between this and this for you to see where the graph goes. So here in this scenario, you will, meaning, see, this has to be an extended graph. I can continue with this next week, but the only thing I wanted to bring up here is when there are no horizontal asymptotes, you will have to perform a polynomial division and express it like this and draw your slant asymptote, vertical asymptote, though there are no horizontal asymptote. That's the only thing I want to bring up. Next week, I will extend this discussion on slant asymptotes, do 4 or 5 problems, and then move on to the next unit. Okay? I'll not leave it like this. You get it? Okay, the same thing. I'll put this cheat sheet there in the Google Classroom as well. Okay? For now, do you have any questions? Yeah, I need one more class for this graphing. Any questions?
No.
Okay, I'll stop here, guys.
No.
See you
Bye,
next.
Miss Priya. Have a nice
Yeah,
day.
bye. Bye, ma.
Miss Priya, thank you.
Bye.